Taking probability samples of large populations is considered common practice in the social sciences. Although a random selection process is generally the best way of getting a representative sample from a population, it doesn't guarantee a perfect sample. We must acknowledge that even the best random samples will always be a little different from the true population. We call that sampling error. It occurs when we take a random sample rather than observe every subject of a population. Let's pretend that you are conducting a telephone survey on how much people spend during their summer vacation. You call 1,000 randomly selected U.S. households, and just by dumb luck, after 100 phone calls, you happen to get a hold of Mark Zuckerberg, founder of Facebook, and he agrees to take your survey. Unlikely, but possible. Let's also pretend that after calling 600 people, you also got a hold of Oprah Winfrey. Again, unlikely, but the point I'm trying to make is that if just by random chance or luck we got slightly too many rich people in our sample or too few wealthy people, our sample will look a little different than the true population. That difference is called sampling error. When collecting a sample, we can't avoid sampling error, but we can estimate the size of sampling error, and there are ways of reducing sampling error. The margin of error that you commonly see with survey results is an estimate of sampling error. Because it is just an estimate, there is a small chance, usually 5% or less, that the margin of error is actually larger than stated in a report. We can reduce sampling error by increasing the sample size. That is, you can select more subjects to observe. As your sample size increases, your sampling error decreases, but increasing your sample size also increases cost, both in time and in money. And after about 1,000 cases, you start to get less bang for your buck. As you can see in this chart, after 1,000 cases, even if you more than double your sample size to 2,500 subjects, you only reduce your margin of error by 1%. You can also reduce sampling error with a good sampling design. For example, if your overall population has distinct subpopulations, then sampling each subpopulation independently may reduce sampling error. But these techniques can only reduce sampling error so far. The only way to remove sampling error completely would be to observe every element in a population, which is impractical, if not in some cases impossible. We simply must acknowledge that survey samples are imperfect, but generally a very efficient and accurate way of studying a large, complex population.